Hello everyone. Today I want to share with you some smart and modern way to build and run APIs using AWS services like Amazon ECS, API Gateway, AWS Cloud Map, and Amazon Cognito. Well, if you are an budding architect or a developer, this video will definitely help you understand how these services work together to create fast, secure, and scalable APIs using containers. So let's get started. So here's an architecture that we're going to review today. And here you see we have multiple AWS components. We have the API gateway, and that's sitting right before a couple of ECS services that are in an auto scaling group. And that ECS service is sitting right before an DynamoDB, meaning it's putting and getting data from those DynamoDB tables. And we see two DynamoDB tables, one for pets and one for food. And we see two ECS service, one for pets and one for foods. And there's one API gateway that's actually exposing these two services to external users or internet. And we also see an cloud map. We'll talk about cloud map little later. And we also see an Cognito, which is an user authentication service which has registered users. Only registered users can authenticate themselves against it and gain more access as they want. All right, so this is the architecture that we're going to review. And in specific, right, we're going to look at or talk about how API Gateway plus Cloud Map plus Cognito, they three work in cognizance and create an serverless and secure API. So you must be aware many companies today build their APIs inside Docker containers. Think of containers like small boxes that hold your app and everything it needs to run. But to make these container apps available on the internet, you need a system that actually can send those web requests to the right containers and scale the number of containers up and down, like in this architecture. So, scale the number of containers up and down automatically and keep everything safe and available. So, first, let's talk about managing containers. On AWS, right, we can use Amazon ECS, Elastic Container Service, or Amazon EKS, Elastic Kubernetes Service, to manage these containers. We can run containers on servers and we manage them, and that's the EC2 service. Or we can also use serverless options like AWS Fargate. Now with Fargate, Fargate has some advantages over EC2 container type. So with Fargate, right, we don't have to manage any servers. Amazon manages those servers for us. So usually when people use, and in order to expose those APIs, right, people generally use load balancers to send internet traffic to the containers. But there's also another way. Well, the better way is to use API gateway along with cloud maps, just like the way we have used and just like the way I've showed it to you. Yeah. So the better approach is to use API gateway, which acts as a front door for all our APIs, and along with that, use a cloud map, which is like an smartphone book for the service. It automatically kind of scans ECS and identifies all the active services running at any given point of time. Remember, we're talking about ECS, which is scalable and flexible, meaning when there is more demand, more services gets launched. So previously there were four, now there could be like eight. And API gateway needs to be aware of all those eight services running inside that ECS, so it can send the traffic to those eight ECS services in a load balanced fashion. And sometimes when there are no requests coming in, that four services can now come down to two service. And again, that also needs to be updated to API gateway, meaning all the services that got retired or deleted because of no usage, right? So to save cost, they needs to be reported back to API gateway. So API gateway keeps track of that, meaning it's not API gateway which keeps track of that, it's the cloud map which keeps track of that. So cloud map is like the smartphone book for all our services. So how does an API gateway work? The API gateway manages the API routes, meaning the URLs and the methods. So when it receives, right, it checks the URL and checks the method to which it has been addressed to, and it uses that and sends a request to the appropriate service behind it. And API gateway does authentication. API gateway does throttling. API gateway monitors what's going through it and provides the metrics. And API gateway provides security, more security through a token validation, right? So these are the things, or this is how an API gateway works. Now, how does an cloud map work? Let's talk about that. So here's your API gateway, and here is your cloud map. Let's talk about how a cloud map works. So how does this work? Amazon API Gateway acts as a front door for our API, and it manages which URL paths, HTTP methods go to which container behind it. Right. It also adds some useful features like, user authentication, traffic control. Let's look at this architecture and we'll talk about Cloud Map. Now, Cloud Map is like a smartphone book for our service, and it actually helps API gateway find the right containers even when the number of containers change because of scaling up and scaling down in the ECS service. So this means that API gateway, it always knows where to send the request without hard coding any IP addresses or URLs to it. So that logic, that function is completely offloaded, or it's not at all present. So that logic, that brain, that thinking is done by the service called Cloud Map. So let's apply what we have learned here. The API has two parts, right? As you see, a food store and a pet store. And anyone can get the data from these stores, meaning the get operation can be done by anyone. But only the signed users can add data. In other words, only the signed users can put data to it. So to handle this, this solution uses Amazon Cognito for user sign-in and token management, and Amazon DynamoDB to store the data that the request will have to fetch and give back to the user. The get access is public, but the put access, for somebody to put data into it, they need to be authenticated. And that authentication is done by Cognito, by user sign in and Cognito providing the token. And the data that needs to be fetched, or the data that needs to be put, is present in DynamoDB, which is our data storage here. Next, let's talk about Fargate. So as you know, Fargate is serverless, and we don't have to manage any servers. Fargate can scale up automatically based on the CPU usage. So the containers here run on AWS Fargate, which is a serverless, and we don't get to manage the servers. And the system automatically here increases and decreases the number of containers based on the CPU usage, so it can handle more or few users smoothly and seamlessly. Well, we can also apply a load balancer in place of an API gateway. That's it's still going to work, but at this point I think it's important to understand the difference between using an API gateway with a cloud map like we've used here versus AWS load balancer, putting that in front of our containers. Firstly, the API gateway is like a smart manager for your APIs. It does many things. It sends requests to the right place, checks who you are, does the authentication, controls how much traffic comes in, that's throttling, and watches how our API is working, that's monitoring. On the other hand, a load balancer mainly just shares the traffic evenly across our servers or containers, and it does not check who is using our API or even does not do any control on the access. So that's a downside of load balancer here in this application. Secondly, when the containers grow or shrink, right, the containers addresses, they change over time. previously I had like 4 containers running, and a couple of ups and downs happened. And after like 2 hours, if I look at it, it could be a totally different set of containers there with a new set of IP addresses. So that's possible. So the IP addresses change. And AWS Cloud Map works with API Gateway to find the right containers automatically. This means the API Gateway always knows where to send the request. But with load balancers, we need to tell the address manually, tell the instance manually, and or we need to use some fixed groups and attach them as target groups. And this is less flexible when our systems change a lot, when we are setting up a very dynamic environment, a scalable environment. And thirdly, the API gateways give you one simple place for all our requests. It can work with, it can handle different communication types like REST or WebSocket. You can also change request or response if we want, kind of change or manipulate, handle or massage the data, right? That's possible with API. But with load balancers, this is not possible. Load balancers can only send traffic. They do not change the data or support many protocols. That's a drawback in this architecture if we use load balancer. And fourthly, API Gateway gives us detailed information about how our API is used. I mean, the errors, the speed and all that. But in case of load balancers, they only give very basic information about the server health and traffic. That's it, nothing more, right? And one more difference is API Gateway can scale down to zero when no one uses our API. When it is literally idle, it can scale down to zero. We don't get to pay. We get to pay only for the time it is used. But with load balancers, it kind of runs all the time. Kind of adds more cost to our bill. It's fully running even when nobody is using it. So that's a downside of load balancer when we compare it with API. And finally, API Gateway mingles well, or it works well with Cloud Map when we want strong security, control, and easy scaling for our APIs, especially, like I explained, if we have many small services running. But that's not present with the load balancer. So in short, right, we use load balancers when we just want to share traffic simply and don't need all the extra features that the API gateway provides. Just simple traffic forwarding, load balancer will be an appropriate one. So let me now explain how these three services, the one we are focusing, they work together. Let me explain that to you in more detail. Let me open this architecture. So as you now know, API Gateway is the front door. It receives API requests from users and routes them to the right container service running in ECS. And then we have AWS Cloud Map, which keeps track of healthy containers and their IP addresses. When containers scale up or down, Cloud Map is the one that updates API Gateway with the current list of containers. So it's always current and is in sync. This way, the API Gateway always sends request to working and existing containers. Talking about Cognito, Cognito handles user authentication. It manages users sign up and sign in and gives users the needed token called the JWT token that prove who they are when it's challenged against the API gateway. So the API gateway uses these token and check if the user is allowed to access certain IP routes. Yeah. And here's the typical flow. So the user signs in. This is the user experience. The user signs in with using Amazon Cognito and gets a token. The client adding the token to it. The API gateway checks the token, kind of checks with Cognito and make sure that the token provider is valid, kind of passes that token and gets an okay from it saying that yeah, this token is valid and this is the access this token has, on and on. If the token is valid, the API gateway uses AWS Cloud Map as next thing to find the right container instance. And after that, the API gateway forwards the request to the containers running in container or containers running in ECS, be it the pets service or be it the food service, depending on which is the appropriate one, it sends the request to it. The containers then process the request and respond by often like storing the data in DynamoDB or kind of retrieving the data from DynamoDB, depending on whether it's a put action or a get action. That's what happens. And that's the flow and function of this architecture. So why is this architecture good? Let's talk about that. Security. Authentication here is handled by Cognito. So you don't need to build it inside your container. Yeah. So that security part is handled by Cognito. This architecture has stability. Containers can scale automatically, and the cloud map keeps API gateway updated with the healthy containers. So this architecture as a whole has stability. Simplicity. The API gateway manages routing, security, and monitoring, all that in one place. So it's simple. And this is all built on serverless services. We could have used EC2, but here we're using AWS Fargate, which means there is no server management role or responsibility from our side. And on top of that, we can pretty much control the actions that need authentication and the actions that does not need authentication, the actions that's public and the action that's not public. And I explained that to you, the put and get action. So the benefit of this architecture is the security is handled by Cognito. It's scalable. ECS and Cloud Map, they work together, and scaling, and there's no issue because of scaling up or scaling down. And it's very simple. It's kind of centrally managed through an API gateway, and all the component here is serverless. We don't get to manage the underlying infrastructure, which is cool. And flexibility it offers, the fine-grained control, or having fine-grained control over the put and get action. Now let's talk about choosing the right tool. So to summarize, use API Gateway plus AWS Cloud Map to expose your container APIs securely and easily, because API Gateway adds features like authentication and traffic control that normally load balancers they don't provide. And AWS Fargate, it lets us run containers without managing servers, right? So we could choose AWS Fargate over EC2. So this setup is great. Serverless, scalable, and secure API architecture. Well, if you don't need all the features of the API gateway, you can still use the traditional load balancer method like the application load balancer. But it's important to pick the right tool for your needs. So this type of architecture, this type of functionality requires an API gateway. Right, let's conclude. So that's all for today. Remember, Amazon API Gateway helps send requests to your app and keep it safe. And AWS Cloud Map finds your app containers when they change or grow. And Amazon Cognito helps users sign in and checks who can use your API. And together, all these services make your API very much easy to manage. It secures the architecture, and it's able to handle many users. Thank you for watching. If you have questions, write them in your comments.